Hi, this is question number 9 from section 14.1. So this is 14.1, number 9, and it's about the time value of money. Okay, so let's take a look at what we have here. To solve these type of problems, we're going to look at we're going to start with the base formula here, where our principal is equal to our a1 plus I to the nth. We can solve this equation and move things around so it actually has our a value over here. It might be a little bit easier to work with. Alright, so let's list out what we know so far. So our average annual inflation rate is 9.4, and basically it's saying how long will it take for our general level of prices in the economy to double. It would take about blank year for the level of the prices to double. So let's take a look at some values here. Okay, so when we're working this out, let me pull that back up where we were. Sorry about that. Okay, so the deal is that we don't have dollar amounts. So we can kind of just establish $2 amounts. So we can kind of talk about, let's say, like for example, our starting value, our P, our initial principal. Let's just say it's $1. So therefore, our A is going to be $2 because that's a doubling. So with that said, what we're going to basically do is plug in what we know here. So we have our A. Let's talk about I also. So our I is our percentage rate. Our percentage rate is 9.4%, which means that we're going to change this to 0.094. So we plug in what we know. And n. Now you notice n is equal to, let's just say the number of years for this to occur. So what we're looking here is basically like an exponential function. And what's going to happen here is, since our exponent is our variable, we're going to have to use something that's kind of new to us called logarithms. And so once I get to that spot, I'll kind of talk about that a little bit. Alright, so here we go. I'm going to need a little more space here, so I'm going to slide that up a little bit. Alright, so now we continue to solve through, and at this point what happens is that we have, let's see, well, we can't do anything with inside of here, so we could kind of, I guess, divide by 1, which really doesn't do anything for us, but I just wanted to show you the idea. So we would divide by 1, and what would happen here is that those 1's cancel. That leaves us with 1 plus 0.094 to the nth power equals 2. So now let's discuss logarithms for a second. Let's discuss the concept of logarithms so that we can kind of use that as a tool for what we need. Okay? So with logarithms, we have a scenario where if we have an equation, like, and I'm going to change, the variables are going to be a little bit different, but if like we have y equals b to the x, and we want to solve this thing for x, we have something called logarithms. And so what we can do is we can take the log of both sides. And really what it is, it's a property. Okay, so all I've done there is I've slipped the log in front of both things. I've done it to both sides. It's no different than, like, think about it, if I had an equation like y plus 2 equals 4, and I subtract 2 here, I subtract 2 here. Whatever I do to one side, I have to do to the other side. Well, what this actually allows me to do, it allows me to take this exponent and move it down in front. Okay, so what's happened here is that we've put something in log base 10, and log base 10 is a button on our calculator that we can use. Okay, so we now have a situation where we have, on this side, we have log, I'll leave that 10 in there so you kind of start understanding this is base 10, equals, that x is now down in front, times log base 10 of b. So this is kind of my basic property. So now now that my variable, my x, is down in front, I'm actually able to continue with the problem and solve this with my calculator. So at this point, on this side right here, I'm ready to log both sides. So I'm going to log, come back up and write things in. Okay, so now that I've done this, that allows me to bring this guy down in front, which now gives me, oops, go to red, log base 2 is equal to n times log 1.094. Okay, and all I did is went ahead and add what was inside the parentheses there to put it together. Alright, so at this point, we're really close. We're going to go ahead and get n by itself. So the inverse of multiplying by this log is to divide by this log, because this log is an actual number. If I do it to one side, I have to do it to the other side. Alright, let me pull up my calculator real quickly and kind of show you what happens. On the right hand side here though, those cancel, so I'm left with n equals, and just give me 1 minute to pull my calculator up. Alright, here we go. So I'm going to go ahead and you'll notice, let's see, about right here, this is my log button. That log button is in base 10. What it means to be in log base 10 is that log base 10 is our number system. We're in the base 10 number system. If this problem said log base 8, log base 5, we wouldn't be able to do this process, so it'd be a little bit different. But at this point, we take the log of 2, close the parentheses, divide it by the log of 1.094, close parentheses, press equals, and so we come out with n is equal to 7.715. Okay, so let's look at the context of the situation. Let's go back and look at the question here. Got to change that back like that. Sorry about that. All right, it would take about blank years for this general level of prices to double. Okay, do not round your final answer. Then do not round until your final answer. Then round to the nearest whole number as needed. So in this case here, what we're seeing is that if we get to the spot, if we get to the spot and we try to take a look at what we have, we see we have 7.715. I was having trouble with getting there if you couldn't tell. And so in that case, what's going to happen is that's going to round up and say that it's going to be about 8 years. It's going to take us about 8 years with this percentage rate. Okay, so let's go back up there. We're using a percentage rate of 9.4%. It'll take us about 8 years for us to double our investment, to double based upon our annual inflation. Okay, so that's using logarithms to solve an exponential function, to solve for that variable when it's in the exponent.